This is Leslie and Laura, and we're going to talk a little bit about something called pH. When we say pH, what does that mean to you? What comes to mind?
Acids and bases.
Great, because pH is a way that we determine if something is an acid or a base. Any other words that come to mind, Laura?
Concentration, solution.
Concentrations of solution. That's a great idea, because that's what pH is. The definition says it's the measure of hydrogen ion concentration in solution. Now, one thing most people don't understand about pH, if something has a pH of 7, it's said to be neutral. If it has a pH less than 7, a pH of 6 or 5 or 4 or 3, it is an acid. And the farther you are from 7, the stronger the acid is. So if it has a pH of 6, if it had a pH of 5, it would be 10 times stronger. If it had a pH of 4, it would be 100 times stronger than 6. Same thing works with bases. As we go past 7, 8 is a weak base, 9 is stronger 10 times, 10 is 100 times stronger than 8, and every time you go out, it's a power of 10. Let's look at some of the things on the table. Some common things, some things you might recognize, some things you might even eat, and let's determine if they're acid or base. Now, to do that, we're going to use an indicator. This is called pH paper. And in pH paper, you take one of the little strips, go ahead and tear one off. About a 2-inch strip. Now, what we're going to do is we're going to put it in one of our liquids. Then I want you to hold it up against this standard, and we're going to match the color. If it has this color, then it has that pH. Okay, you ready to do the first one for me? Okay, just shake off the excess like you're doing, Leslie, and hold it right up here, and let's see what you think it is.
It looks about a 13.
Great, 13. All right, so let's write up on our scale here what that is. This is a cleaner, a household cleaner, spray bottle type, right? So, this is a cleaner, and it has a pH of 13. Now, think about this a second. If the pH is 13, would it be safe for you to drink something with a pH of 13? And you're right. You know, it could be hazardous. It could even be damaging to you. You could kill yourself by drinking something that strong. Okay, ready to do the next one, Laura? Okay. By the way, you did recognize those, right?
No.
Tomatoes. Did you have any tomatoes for lunch?
No.
No. And if you had, the pH would have been what?
That.
Let's hold it up here and make sure. Okay, that looks good. pH of 5?
Mm-hmm.
All right, so is that an acid or base?
That's acid.
Good, I agree. Would you say it's a weak or a strong acid?
Weak.
Okay. Tomatoes. All right, let's try our next one. Ready? By the way, before you put this one in, just hold it over the top of the glass and let's watch the color change. You see the color's already changed?
Mm-hmm.
This one has a strong aromatic property. That means it gives off vapors. All right, let's go ahead and touch it now and watch the color change. Okay, pull it out. Okay, that was ammonia. And ammonia is a strong base also.
11.
Looks like 11?
11.
Okay. Base, strong base, weak base?
It's pretty strong.
It's pretty strong. That's right. Would you want to drink ammonia?
No.
No, of course not. We're making us a pH scale based on some things you would recognize, some common substances. 1 to go. Yeah, pH is 6. It's less than 7, but you can tell it's in the neighborhood between 6 and 7. That's water. Now, we said that pure water had a pH of 7. why do you think that this water that we had that came right out of the tap, why do you think it has a pH less than 7?
Because it's been contaminated.
Great, it's been contaminated. The term we use for that is called acid rain. Acid rain is caused by contaminants that we put in the air. Things like, let's list a couple of them, like carbon dioxide. We produce carbon dioxide when we breathe. Carbon dioxide also is produced by burning fossil fuels, burning coal, burning gasoline. Okay, one other one that's produced by fossil fuels is sulfur dioxide. Now, let's see how these things make acid rain. These are contaminants that are put into the air to cause air pollution. So let's add them to water vapor. Carbon dioxide plus water yields carbonic acid. Sulfur dioxide plus water yields sulfuric acid. So those contaminants are put up into the air. They join with water vapor there and fall down as acid rain. So instead of having a pH of 7 like pure distilled water would have, the pH might be 6 or 5 or 4. The record low pH is a pH of 3. Now that would have the same sort of characteristics as vinegar or cola. It would be sour to the taste. Now think about the problems that having a pH of 3 would have. If rain with a pH of 3 fell on plants, what do you think would happen to them? What about it, Laura?
They'd probably die.
And if they didn't die, they'd be stunted or burned. All of this is caused by adding acid to the rain that produces acid rain. Let's see if we can do something to correct that effect. Okay? Let's see if you produce some acid. When we breathe out, what's the gas that we release?
Carbon dioxide.
Great, you both got it, carbon dioxide. Okay, so if we combine carbon dioxide plus water, we should produce a mild acid, carbonic acid. Now, I have a second type of indicator. The first indicator we used was the paper. And the paper measured pH all the way from 0 up to 13. Now, we're going to have an indicator, this liquid. This liquid contains called bromothiamyl blue. BTB, it has a color change from about 6.5 down to about 5. Now notice the nice color. Hold it up so our camera can see that nice blue color. Nice bright crystal blue. Now I want you to blow in it for me, and we should see a color change. Before you blow, let me give you a little warning. One, it's not Kool-Aid, right? We don't want to drink any of it. And second, don't blow so hard that you splash it out on you, because it's a pretty good dye. Okay? Let's go ahead and blow and give us a color change here. The color change should go from blue to green to almost yellow. And this is a pretty good yellow. I think you're 3. Let's see how yours is looking now. Okay. So in terms of color change, this is a part of the way, if you kept blowing, you would eventually wind up with this yellow color. So we have changed the pH from about 6.5 down to about 5. Now, we talked about the pH has been lowered. It has become more acidic. Let's see if we can reverse that process and move it back up towards 7. Now, the way we do that is by adding something called a buffer. And a buffer has the ability to change the pH and to move it back towards neutral. So if we put a buffer, for instance, in an acid, it'll move it back up towards 7. If we put a buffer in a base, it'll move it down towards 7. Now, what you've just done, you have lowered the pH and it looks nice and yellow. So let's add a little bit of our bicarbonate of soda, baking soda, and we should see a nice color change. Let me hold this up for you here so that you put it in, we'll see the color change on the camera. And that should be plenty. And when we shake it up, it goes right back to that nice blue color again. Think about our acid rain problem. When we put carbon dioxide and sulfur dioxide up into the air as air pollution, it causes acid rain, which lowers the pH. Now, we put baking soda in the solution to change the pH and move it back towards 7. How could we change the pH in the lake? If the lake water gets down to 6, how do we get it back up towards 7?
By adding limestone.
Well, she's been reading the textbook, hasn't she? That's exactly right. Baking soda, of course, would cost too much for us to put in there. It would be difficult for us to find enough baking soda to change the pH of an entire lake. But you could put limestone, crushed limestone, which is found in rocks. In fact, some soil contains enough limestone to where that acid rain does not hurt it because it was basic to begin with. So if you have alkali kinds of soils, like these folks in New Mexico do, a little bit of acid rain doesn't hurt them. It just moves their pH down towards 7. And if they had enough acid rain, it would cause a problem. We, however, we live in an area that doesn't have limestone as the natural country rock. That's the predominant rock. What we have instead is granite. And granite is acidic in nature. So if you put acid rain on an acid rock, you just compound the problem. But unfortunately, it's not possible to put enough limestone in all the lakes to cause the pH to go back to where it was originally. So we need to do something about reducing pollution instead. Give me a couple of examples of ways we could reduce pollution. Give me one, Laura.
When cars, when they pollute,
Okay.
the burning fuel.
Burning fuel. Okay, we could reduce that. Okay, name some ways that we could reduce the amount of pollution produced by cars. Think of some things we might do with cars.
You could carpool.
Carpool. That's a great way. Okay. What about if you lived on the post instead of driving your car? What could you do? You could walk, right? You could walk or ride a bike. During my lifetime, we have been using large quantities of fossil fuel, coal and petroleum. And in your lifetime, we're going to use those resources up. So not only is it beneficial for us to go ahead and reduce our usage, to reduce the effect of acid rain and pollution, but to save some of those resources for you to use.